Hello. In this segment, we're going to explore building triangles within the coordinate plane. And the reason that we're going to do that is because we want to build the unit circle eventually. So we're going to take this segment of information and talk about how we use the coordinate plane in general. And then in the next segment, we'll take the coordinate plane, build a unit circle from scratch, and show how the use of triangles within the coordinate plane helps us to figure out what all the values in the unit circle really are. So we're going to start with just building a triangle within the coordinate plane. Let's suppose that we have a point somewhere on the coordinate plane, and it doesn't really matter where it is, and if I was in class I would probably take suggestions, but at the moment you can't answer me, so I'm just going to pick some points. So let's say that our coordinate plane point is, I don't know, -5 and +12. Okay. Now I'm not going to get overly precise as I'm drawing these because quite frankly it's not necessary. I'm not trying to compare lengths and all that kind of thing, so scale's not really important right now. I'm just going to put them in the right general space. -5 would be on the negative side of the x-axis, +12 on the positive side of the y-axis. I'm going to be happy with that. So I have this point out here in space, which is -5, +12. What I'm going to do with that information is I'm going to build a right triangle. Now, there are two ways to build a right triangle from this point. Actually, there's several ways to build a right triangle from this point. And so it may not seem obvious to you which way is the right way. But let me assure you that there is only one way that you're going to build a right triangle in this space, and that is from the origin. The origin will always be one of the vertices of your right triangle. So automatically, here's our hypotenuse. Now the question is, do we build a leg down from the point to the x-axis or over from the point to the y-axis? Well, the answer to that question is always down to the x-axis. The reason for that is because we can use reference angles then to determine some of our trigonometric values. And theta is always going to be snugged right in here next to the origin. So what we're looking for are is a right triangle that's built from the point that's out in the coordinate plane. It has a leg down to the x-axis. The x-axis itself would be the other leg, and the point from the origin to the point is, or excuse me, the line from the origin to the point is going to be your hypotenuse every single time. This is always, always, always the way that you want to build these, so just keep that in mind. Now from here, what we need to do is go ahead and label the sides. So what I know about this particular right triangle is that it has a base of -5, and it has a height of 12, and then I need to figure out what the hypotenuse is. That's easily enough done. Using the Pythagorean theorem, I can say that 12 squared plus -5 squared should be the hypotenuse squared. 12 squared is 144. 5 squared is 25. When you add those together, you get 169, which means if that's the hypotenuse squared, then 13 is the hypotenuse. So I'm going to go ahead and label this side over here as 13. And yes, I did do that on purpose because the Pythagorean triples do make life a little bit easier. Although they're not absolutely necessary. You can find information without using the Pythagorean triples. You can use radicals and all that kind of stuff. But for the purposes of our exercise here, we're going to use some nice pretty numbers because it just makes everything seem easier. So from here, what we're usually asked to do is to find the 6 trigonometric values of the angle formed by the x-axis and the line that connects -5, 12 to the origin. And so in order to do that, now all we have to do is line up our trig values, sine, cosine, tangent, cosecant, secant, cotangent, and if you've watched any of my videos before, you know that I always write them in this grid because I just find it easier to keep up with what's going on. So you may or may not remember the mnemonic device, SOHCAHTOA, that helps us to remember which trig value takes on which sides, but let's go ahead and use that. So the sine of theta would be the opposite over the hypotenuse, so 12 over 13. The cosine would be negative 5 over 13, adjacent over hypotenuse. And the tangent would be opposite over adjacent, or negative 12 over 5. Notice that I put that negative out in the middle there, because what I'm doing is applying the rule that a positive divided by a negative is a negative. It doesn't really matter where that negative winds up. It's just negative. Excuse me, I'm going to move the camera just a little bit without breaking the whole operation here so that you can see the whole thing. All right. That's not cool. Okay. So, and then the nice thing is to do cosecant, secant, and cotangent, you just flip everything over. So the cosecant is 13 over 12. Secant is negative 13 over 5. And cotangent is negative 5 over 12. And there we have our 6 trigonometric functions. Well, then let's look at this in a little bit more generic sense. I'm going to erase this information. I'm going to leave my triangle up there, though, because what I want you to do is to start considering things in a little bit more generic sense. What is the general rule here? Because once you've done that, you actually don't necessarily have to draw the triangle every time, although, quite frankly, I like to, just because I'm a very visual person. But what I like to think about is, what are the generic rules now here? If I have a point, x, y, in the coordinate plane, that means that the base length of this triangle, when I draw it, is x, and the height is y. Okay, what that does is it allows me to do some basic figuring. I also know that the hypotenuse over here, I'm just going to label it with h. I know I can find that using the Pythagorean theorem. I've been using the Pythagorean theorem for some time, so hopefully by this point I'm confident that I can use the Pythagorean theorem to find what I need. So let's find sine, cosine, tangent, etc. So the sine would be opposite over hypotenuse, or y over hypotenuse. The cosine, adjacent over hypotenuse, or x over h. The tangent, opposite over adjacent, or y over x. And then, of course, we flip them. So we've got hypotenuse over y, hypotenuse over x, and x over y as my cosecant, secant, and cotangent. And so what this does is it lays down a foundation of, if I have a point within the coordinate plane, I can build my right triangle from the x-axis up to that point, and then from there I can find my 6 trigonometric values simply by applying x and y and the hypotenuse in question, and I can find the 6 trigonometric functions of any point on the coordinate plane. It doesn't matter what it is. We should be able to follow these same rules and make that happen. So I'm going to stop the video now, and we're going to pick up on this, and we're going to build the unit circle using these same principles along with the perfect right triangles, the 45, 45, 90, and the 30, 60, 90 that we've used before.